Come back. Chapter 2, Organizing Data, Section 2.3, Stem and Leaf Displays. So focus points in this section are construct a stem and leaf display from raw data, use a stem and leaf display to visualize data distribution, compare a stem and leaf display to a histogram. Let's look at exploratory data analysis. Together with histograms and other graphics techniques, the stem and leaf display is one of the many useful ways of studying data in a field called exploratory data analysis, or often abbreviated as EDA. John Tukey wrote one of the definitive books on this subject, Exploratory Data Analysis, published by Addison Wesley. Another very useful reference for EDA techniques is the book Applications, Basics and Computing of Exploratory Data Analysis by Paul F. Wellerman and David A. Hoagley, Duxbury Press. Exploratory data analysis techniques are particularly useful for detecting patterns and extreme data values. They are designed to help us explore a data set, to ask questions we had not thought of before, or to pursue leads in many directions. EDA techniques are similar to those of an explorer. An explorer has a general idea of destination, but it is always alert for the unexpected. An explorer needs to assess situations quickly and often simply and clarify them. An explorer makes pictures, that is, maps showing the relationships of landscape features, the aspects of rapid implementation, visual displays such as graphs and charts, data simplification and robustness, that is, analysis that is not influenced much by extreme data values, are key ingredients of EDA techniques. In addition, these techniques are good for exploration because they require very few prior assumptions about the data. EDA methods are especially useful when our data have been gathered for general interest and observation of subjects. For example, we may have data regarding the ages of applicants to graduate programs. We don't have a specific question in mind, not yet, right? Now, we want to see what the data reveal. Are the ages fairly uniform or spread out? Are there exceptionally young or old applicants? If there are, we might look at other characteristics of these applicants, such as field of study. EDA methods help us quickly absorb some aspects of the data and then may lead us to ask specific questions to which we might apply methods of traditional statistics. So first we want to explore the information and then proceed to specific questions. In contrast, when we design an experiment to produce data to answer a specific question, we focus on a particular aspects of the data. If we want to determine the average highway gas mileage of a specific sports car, we use that model car in well-designed tests. We don't need to worry about unexpected road conditions, poorly trained drivers, different fuel grades, sudden stops and starts, etc. Our experiment is designed to control outside factors. All right. So, consequently, we do not need to explore our data as much. Methods of traditional statistics will be very useful to analyze such data and answer our specific questions. Okay, so that was a little bit on exploratory data analysis. Now, stem and leaf display. Okay, we will come to this in our next video. Until then,